Welcome back to my channel. This is Erwin Angelo V. Baduria, your math teacher. For this video, we will be tackling about general annuity. At the end of this video lesson, you should be able to illustrate a general annuity and find the future value and present value of a general annuity. The terminologies of general annuity are the same as the terminologies of simple annuity. Again, simple annuity is an annuity where the payment interval is the same as the interest period. Example below, we have 15,000 pesos every month and 8% compounded monthly for the interest rate. The regular payment and the interest rate have the same period of interval. They are both in months. For general annuity, this is an annuity where the payment interval is not the same as the interest period. Example below, 15,000 pesos every month and an interest rate of 8% compounded quarterly. The regular payment of 15,000 and the interest rate have different period of interval. For the regular payment, we have monthly, and for the interest rate, we have quarterly. Term is denoted by lowercase letter t. This is in years, that is between the first payment and the last payment. Regular payment or periodic payment is denoted by R. Amount of annuity is denoted by A, and the present value is denoted by P. Let me introduce to you the formula of general annuity. For the amount of annuity, that is equal to R times the bracket of the quantity 1 plus I sub m over m raised to mt minus 1 all over I subscript m over m. The value of the regular amount when the annuity is provided is equal to A times I subscript m over m all over the quantity of 1 plus I subscript m over m raised to mt minus 1. For the present value P, it is equal to the regular payment times the bracket of 1 minus the quantity of 1 plus I subscript m over m raised to negative mt all over I subscript m over m. Now, the amount of the value of the regular payment in this formula is equal to the present value times I subscript m over m all over 1 minus the quantity of 1 plus I subscript m over m raised to negative mt. The formula for the equivalent rate is essential in this type of annuity. The equivalent rate formula is equal to m times the bracket of the mth root of the quantity of 1 plus I subscript n over n raised to n minus 1. Example number 1. Find the present value of a monthly payment of 2,000 pesos for 3 years with an interest rate of 5% compounded quarterly. We are looking for the present value when there is a monthly payment of 2,000 pesos. So we have the regular payment is equal to 2,000 pesos. And this in case we will be representing the conversion units of the regular payment as M, which is 12 monthly. The term is 3. And the interest rate is 5%. I subscript 4 is equal to 5%. And that is N is equal to 4. For the rate, we have N is equal to 4. And for the regular payment, let's represent it by M, which is monthly. Observing the value of M and N, they are different. Therefore, the payment interval of the regular value and the amount of interest are different. So we have to synchronize them by converting 5% quarterly into monthly. So it should be synchronized with the regular payment. The one that is to be converted is the interest rate into what we need, which is monthly. So we have to find the monthly rate of 5% quarterly. So in this case, we are looking for the equivalent rate of 5% compounded quarterly into a certain value of rate compounded monthly. So in order to do this, we have to use the equivalent rate formula. The formula is I subscript M equal to m times the mth root of 1 plus I subscript m, n over n raised to n minus 1 outside the radical. So we are looking for I subscript 12, the rate in terms of 12 or monthly. So we have 12 times the 12th root of 1 plus our I subscript n is 5%, so that is 0.05 over 4 raised to 4 minus 1. So to continue, we have I subscript 12 is equal to 12 times the 12th root of what is 0.05? 0.05 divided by 4 is 0.0125. That is raised to 4 minus 1. Continue, we have I subscript 12 is equal to 12 times the 12th root of 1 plus 1.0125 raised to 4. It's 1.0125 raised to 4 minus 1. So we have to get the fourth power of 1.0125. The fourth power of that number is equal to, so our new radicand will become 1.050945,337 minus 1. And then we have to get the 12th root of this number. The 12th root of our radicand is 1.004149425 minus 1. And then we have to subtract 1 inside the bracket. So we have I subscript 12 is equal to 12 times 0.004149425. And we have to multiply these two numbers. It will give us 0.0498 in 4 decimal places, or this is the same as 4.98%. Meaning, our 5% compounded quarterly is equivalent to 4.98% monthly. So our 5% compounded quarterly is equivalent to 4.98% compounded monthly. Okay? So this is what we need. What we have rather. That's 4.98. Now, the rate is not we are looking for. We are looking for the present value. The rate is just the initial procedure in determining the present value. So let's find the present value since we already have our 4.98% compounded monthly, which is synchronized with the regular payment of 2,000 pesos monthly. So the formula for the present value is equal to R times 1 minus 1 plus I subscript m over m raised to negative mt over all over I subscript m over m. Now substituting the values that we have the regular payment of 2,000 pesos times 1 minus 1 plus our m now is 0.0498 over, that is 12, our m is 12, raised to negative 12 times the term of 3, close bracket, all over 0.0498 over 12. So continuing the process, let's solve the numbers inside the quantity. So we have 2,000 pesos times 1 minus, that is 1 plus 0.0498 divided by 12 is already equal to 1.00415 raised to negative 36 over The denominator is just 0.00415. So continue. Our present value is equal to, we have to get the negative 36th power of 1.00415. So we have 2,000 pesos times 1 minus the negative 36th power is equal to 0.8614908449 over the denominator, that is 0.00415. Then we have to subtract the number inside the bracket. The number is inside the bracket, so we have 2,000 times, subtracting this, we have 0.1385091,551 over 0.00415. After that, we can now multiply the numbers in our numerator. 2,000 times the number inside the bracket. That will give us 277.0183102 over the denominator of 0.00415. Dividing these two numbers, we have in two decimal places, we have 66,751.40 pesos. So the present value is 66,751.40 pesos if there is a monthly payment of 2,000 for 3 years. And the rate is 5% compounded quarterly. Item number 2. Imbong started to deposit 10,000 pesos triannually. If the fund pays 4% compounded monthly, then how much money will he have after 3 years? So we are looking for the amount of annuity, but let's start determining the values that we have in our worded problem. So Imbong started depositing 10,000 pesos triannually. So we have a regular payment of 10,000 pesos, that is M is equal to 3 because triannually, that's triannually 3 times a year. 10,000 pesos 3 times a year. If the fund pays 4%, so we have I is equal to 4% compounded monthly, so that is I subscript 12 and our N is equal to 12. 4% compounded monthly. Then how much money will he have after 3 years? So the amount of money after 3 years is the annuity, and the term is 3. The term is equal to 3. Now let's analyze this problem so that the number of conversion units of the regular payment and the interest are different. For the payment, regular payment, that is triannually, and the interest is 12, that is monthly, by months. So in this case, we have to synchronize this by converting 4% monthly into triannually. So we are looking for the equivalent value of 4% compounded monthly into an X% compounded triannually. So we have to do the equivalent rate. So I subscript M is equal to M times the mth root of 1 plus I subscript N over N raised to N minus 1. Substituting the values, we have I subscript 3. We are looking for I subscript 3. So we have 3 times the third root of the radicand. We have the radicand as 1 plus our I subscript N is 0.04 divided by 12 raised to 12 minus 1. And then I subscript 3 is equal to 3 times the third root of the number inside the quantity is 0.04 divided by 12 is 0.033333 plus 1, that is 1.03, and 3 is repeating non-terminating decimal or number in the decimal, so we have that kind of symbol, the vinculum, raised to the power of 12 minus 1. So we have to get the power of 12 and then the third root of the radicand. The power of 12 of 1.03333333 is 1.0407 41,543 minus 1. And then we have to get the third root of the new radicand. That's the third root of the new radicand is equal to 1.013,400,148 minus 1. Subtracting the numbers inside the bracket, we have I subscript 3 is equal to 3 times 0.013448. And then, so we have 148, 00148. Multiplying the two numbers, the product is equal to, in 4 decimal places, 0.0402. Or that is the same as 4.02%. Therefore, our 4% compounded monthly is equivalent to 4.02% compounded triannually. After that, we can now determine the value of the annuity. This is just the initial calculation before we go to the calculation of the value of the annuity. Why? Because we have to synchronize first the period of the regular payment and the rate. So this is for the rate triannually, and this is for the regular payment also triannually. So let's proceed with the formula of annuity. So annuity is equal to the regular payment times 1 plus I subscript m over m raised to mt minus 1 over I subscript m over m. Substituting the values, we have 10,000 as the regular payment times 1 plus our I subscript m is the new calculated rate, that is 0.04202 over 3, that's triannually, raised to 3 times the number of terms is 3, close, minus 1 over 0.0402 over 3. So the annuity is now equal to, let's simplify the number inside the quantity and the denominator. So we have 10,000 times 1.1 plus 0.0402 over 3, 0.0402 divided by 3 is 0.0134. So this is the same as 1.0134 raised to 9 minus 1. All over, dividing the numbers in the denominator is the same as 0.0134. So let's continue. Annuity is now equal to, we have to get the power, the 9th power of the number inside the quantity. So we have 10,000 times, the 9th power is the same as 1.12727039 minus 1 over 0.0134. And then, we have to subtract the numbers inside the bracket. Therefore, we have 10,000 times 0.12727039 over the denominator of 0.0134. Multiplying the numbers in our numerator, we have 10,000 times the number inside the bracket is the same as 1,272.703901 divided by the denominator of 0.0134. Dividing the numbers, we have an annuity of equal to 94,977.90. Thus, after 3 years, Imbong will have 94,977.90 pesos. For your practice, we have 2 items. Number 1, Mr. Pangilinan paid 350,000 pesos as down payment for a car. The remaining amount is to be settled by paying 15,000 pesos at the end of each month for 5 years. That is 15,000 at the end of each month. If the interest rate is 12% compounded quarterly, then what is the cash price of the car? take note that the regular payment is 15,000 pesos every month, but the interest rate is 12% compounded quarterly. The period of interval for both values are different. So this is a general annuity. For number 2, Will borrowed 100,000 pesos. He agrees to pay the principal and interest by paying an equal amount of money each year for 3 years. What should be his quarterly payment if the interest rate is 8% compounded semi-annually? In this item, it is asking for a regular payment quarterly, but the interest rate is 8% compounded semi-annually. The regular payment period and the payment of the interest are not the same. So this is a general annuity. Answer these questions and comment down your answers in our comment box below. Before we end this video lesson, let me leave you this quotation from Jane Austen, and I quote, "People always live forever when there is an annuity to be paid them." End of quote. I hope you enjoy learning mathematics in this channel. Don't forget to subscribe and click the bell button so you will be able to notify for our new videos. With that, have a great day.